In this video, I'll show you two examples on how to use Pascal's triangle to expand a binomial. Question 1 reads, expand 1 minus x to the power of 6, obtaining the binomial coefficients from Pascal's triangle. To do this, we'll need obviously the Pascal triangle and the binomial theorem, which is stated below. Let's start by defining a and b. A is equal to 1, and since the binomial theorem has a plus in between the two terms, we have to rewrite this so that it looks like this. 1 plus negative x to the power of 6. So negative x is our b. Our n value is 6. And so we can use this triangle and find out what our coefficients are. This way, when we actually use the binomial theorem, we don't need to calculate this part and this part of the formula. We can just use these. So we have 1, 6, 15, 20, 15, 6, and 1. Now this isn't without its challenges. We still have to go through simplifying the a's and b's for each of these terms. Let's start with term 1. We have a to the power of n. That's really easy. A is 1 to the power of n is 6. So we'll simply write down 1 instead of 1 to the power of 6. Our next term is, we have our n. It's 6. So I'll write down plus 6. My a is 1 to the power of 5, because 6 minus 1 is 5, and I'll reduce that in a moment. And b is negative x. Negative x. So if we simplify this term, we should end up with negative 6x only. Now that I've done that, I can move on to the third term. I know the third term will have a coefficient of 15 plus 15 to start. And we have a to the power of n minus 2. Once again, that's 1. B to the power of 2. That will give us positive x squared. Because, let me show you, negative x to the power of 2, this squared value goes to the negative 1 and goes to the x, leaving us with the following expression. Now to simplify this term, all I have to do is erase that bracket 1, and that's it. So far so good. Let's move on to the fourth term. Starting off with a coefficient of positive 20, we'll use the following, where we have, once again, 1. I don't need to go through this. So 20 times 1, I'll just leave it as 20. And b is negative x. So negative x to the power of 3 is equal to negative x to the power of 3. This means that our 20 is going to become negative, because 20 times negative 1 is negative 20. Our next term, we'll start with positive 15 as the coefficient. But notice that the formula doesn't go beyond the fourth term. In fact, it skips all the terms in between and ends at the last. So we have to improvise. Your next part would be a to the power of n minus 4 and b to the power of 4. Since our a is 1, 1 to the power of anything is going to be 1, so I won't write down 1. The same theme as the previous terms. And negative x to the power of 4 gives us positive x to the power of 4. That's the fifth term in line. Moving on to 6, positive 6, and we'll use a to the power of n minus 5, b to the power of 5. This will become 1, and negative x to the power of 5 gives us negative x to the power of 5, which means that this 6 will become negative. And finally, our last coefficient is 1. So plus 1, we have b to the power of n, which means negative x to the power of 6. Negative 1 to the power of 6 is positive 1. X to the power of 6 is x to the power of 6, leaving us with simply x to the power of 6. Now remember, that was considered easy. This is our final answer. Let's try this once more in question 2. In question 2, they ask us to expand this binomial, and it has an n value of 4, so less work obtaining the binomial coefficients from the Pascal's triangle. So let's go ahead and collect those first. We have 1, 4, 6, 4, and 1. 1, 4, 6, 4, and 1. Also, I've taken the liberty to place the binomial theorem below. That way we don't have to scroll up each time. Let's begin by defining our a and our b. Our a is 3 over x squared. Our b term is 2y to the power of 3, and n is equal to 4. Our first term is a to the power of n. So we have 3 over x squared, all power to 4. 3 to the power of 4 is 81. And x to the power of 2 to the power of 4 is x to the power of 8. So this simplifies to that. Our next term is plus n, and we are using the coefficient 4. A, which is 3 over x to the power of 2, all powered to 3, times b, 2y to the power of 3. 3 to the power of 3 is 27, times 4, that's 108, times 2 is 216. So 216, and the plus is in between the two terms. Y to the power of 3, and this 3 to the power of x to the power of 2 is equal to x to the power of 6. Let's continue to the next term. We are going to use 6 and this part. So a to the power of n minus 2, a to the power of 2, 3 over x squared to the power of 2, and b to the power of 2 this time. So 2y to the power of 3 to the power of 2. 3 to the power of 2 is 9. 2 to the power of 2 is 4. So 6 times 4 is 24 times 9. 24 times 9 is equal to 216. 2 to the power of x to the power of 2 is x to the power of 4. And this becomes y to the power of 6. Our fourth term contains the coefficient 4. And we'll take care of this part. We have 3 over x to the power of 2 to the power of 1, and b to the power of 3. So 2y to the power of 3, all raised to the power of 3. This gives us 4 times 3 times 8. 4 times 3 times 8 is equal to 96. 96, y to the power of 9 over x to the power of 2. And for our final term, we have simply b to the power of n. So 2y to the power of 3, all power to 4. That gives us 16 y to the power of 12. And this part right here represents your final expanded version of this expression. And there you have it. 2 examples on how to use Pascal's triangle to expand a binomial.